Hello students, now today we are going to discuss the Laplace transform, and in lecture 3, so in lecture 1, lecture 2 already we have derived the Laplace transform of that is your some basic functions like t, t square, t cube, etc. That is your t to the power n, that is your factorial n by s plus s to the power n plus 1, and already we have discussed Laplace transform of some exponential function, that is your e to the power minus at and Laplace transform of e to the power plus at. If Laplace transform of e to the power minus at, that is your 1 by s plus a, and Laplace transform of e to the power at, that is your 1 by s minus a. And already also discussed the some hyperbolic function like sin h omega t. In Laplace transform of sin h omega t, that is your omega by s square minus omega square. Now today how to find the Laplace transform of cos h omega t. When that is a sine and cos function and you are going to Laplace transform that function, first of all we have converted cos h omega t. Cos h omega t is nothing but in terms of exponential function. In t, that is your e to the power omega t plus e to the power minus omega t divided by 2, that is your cos h omega t. So that's why now Laplace transform of f of t, Laplace transform of f of t is nothing but what? That is your f of s. So we can say that is your f of t and f of s are the Laplace transform pair. What does it mean? Means Laplace transform of f of t, that is your f of s, and inverse Laplace transform of f of s, that is your f of t. We can say that is your what? Laplace transform of f of t, that is your f of s, and Laplace transform of that is your inverse Laplace transform of f of s is nothing but what? That is your f of t. So already I told you f of s means what? The basic standard formula to find out the Laplace transform of any function. F of s equal to, that is your formula is what? 0 to infinite f of t into e to the power minus st dt. What? So now Laplace transform of what? Cos h omega t. Cos h omega t. In here, so in cos h omega t, we have already expressed in terms of exponential function. So in place of cos h omega t, that is what? Laplace transform of, that is what? E to the power omega t plus e to the power minus omega t by 2. So here, since we know the Laplace transform of exponential function, that is your e to the power minus at, that is your 1 by s minus a, 1 by s plus a, and e to the power plus at, that is your 1 by s minus a. So here already you know Laplace transform of e to the power minus at exponential function in previous class, that is your 1 by s plus a. If it is a minus, that will be plus, and Laplace transform of e to the power plus at, that is your what? 1 by s minus a. If it is a minus, that will be, if it is plus, this will be minus. So that's why here in place of a here that is your omega. So I can write directly here, that is your 1 by 2 Laplace transform of what? That is your e to the power omega t and plus Laplace transform of e to the power minus omega t. Since we have derived Laplace transform of e to the power at and e to the power minus at, that is your what? F of t into e to the power minus st dt, and put the limit 0 to infinite. In this way we got what? E to the power minus at, that is 1 by s plus a. So that's why 1 by 2 in place of e to the power minus omega t, Laplace transform of e to the power plus at is nothing but what? 1 by s minus a. Here a is nothing but what? Omega. So that's why I can write 1 by s minus what? Omega plus here 1 by e to the power minus omega t, that is your what? S plus omega. And the value is how much here? That is your 1 by 2 LCM is your s minus omega into s plus omega. S minus omega all into s plus omega. So that's why s plus omega plus s minus omega. Here plus omega minus omega cancel, and upper numerator, that is your s plus s, that is your 2s. So that is your, which equal to, that is your what? 1 by 2 into 2s divided by s minus omega into s plus omega, that is your s square minus omega square, and 2 will be cancel out. That is your, in numerator that is your s, and denominator that is your s square minus omega square. So therefore Laplace transform of sin h omega t is equal to your what? That is your s divided by s square minus omega square. Okay, sorry, cos h omega t. This is your cos h omega t. Cos h omega t. Okay, if sin and cos, in sin h omega t, Laplace transform of sin h omega t, what? In sin h omega t, already we have derived Laplace transform of sin h omega t is how much? Omega by a square minus omega square. If it is sin term will there, and numerator must be omega. If there is a cos term, that will be your what? If there is a cos term, and numerator must be s. In sin h omega t, the Laplace transform is omega by a square minus omega square. If it is a cos h omega t, the Laplace transform is your s by a square minus omega square. Next. So that is your what? That is your Laplace transform of, already we have derived Laplace transform of sin h omega t and cos h omega t. In Laplace transform of sin h omega t, that is your omega by a square minus omega square, and Laplace transform of cos h omega t, that is your s by a square minus omega square. So then Laplace transform of, if I'll say cos omega t, not hyperbolic function, cos omega t. Here f of t equal to cos omega t. If f of t equal to cos omega t, now we are going to find the Laplace transform of cos omega t. In cos hyperbolic function h omega t, in cos h omega t converted in exponential form, that is your e to the power omega t plus e to the power minus omega t by 2. In case of cos omega t, if we express in terms of exponential function e to the power, the j term will be there, e to the power j omega t plus e to the power minus j omega t by 2 in case of cos function. If I will say sin omega t, and sin omega t value is how much? E to the power j omega t minus e to the power minus j omega t by 2j. So now here in place of cos omega t, you can put what? E to the power j omega t plus e to the power minus j omega t by 2. This is your what? Express cos omega t in terms of exponential function. So that's why you can write here the Laplace transform of, if 1 by 2 taking the left side of the Laplace transform, that is your what? That is your Laplace transform of what? E to the power j omega t plus Laplace transform of e to the power minus j omega t. And the value is how much here? That is your 1 by 2 whole into same thing e to the power j omega t. Already I told you e to the power plus a t, Laplace transform of e to the power a t equal 1 by s minus a, and Laplace transform of e to the power minus a t is your 1 by s plus a. Here a in place of a, that is your j omega. So that's why 1 by e to the plus e to the power plus sign, that will be s minus here a is nothing but j omega, s minus j omega plus 1 by if it is minus, that will be plus, denominator that will be plus s plus j omega. Here a is your what? Here a is nothing but, here in this is nothing but what? Na j omega. E to the power a t in place of a, there is j omega. If it is plus, and denominator that will be minus, if it is minus, the denominator that will be plus. So that's why, so then 1 by 2, and here denominator LCM is your s minus j omega whole into s plus j omega, that is your s plus j omega plus s minus j omega, and j omega cancel, and the value is how much? 1 by 2 whole into, that is your 2 into s divided by, if a minus ib into a plus ib, that is your a square plus b square. So that's your a square plus omega square, a square plus omega square, and 2 will be cancel out, and that will be nothing but what, s by a square plus omega square. So that is your important thing is what, the Laplace transform of cos omega t. So Laplace transform of, therefore Laplace transform of cos omega t equal to your what, that is your s by a square plus omega square. It is very very important when if you apply so any network functions, network, if you convert it into Laplace transform, if it is an, suppose the voltage is your what, some voltage 10 sin omega t or 10 cos omega t, if you immediate transform into that function, and the formula is what, if it is a cos function, cos of any value cos of omega t, that is s by a square plus omega square. Any time domain can be converted into frequency domain, s converted into s, t converted into s, that is your cos omega t, Laplace transform cos omega t, that is your s by a square plus omega square. So already I told you, in case of hyperbolic function sin and cos, if it is a cos function, numerator that definitely that will be s, and if it is an sine function, and numerator must be omega. So keeping in mind, if it is a sine function, definitely the numerator must be omega. If it is a cos function, definitely the numerator is your s. If it is a hyperbolic function, denominator must be s square minus omega square. If it is a simply cos or a sine function, and denominator must be what, s square plus omega square. Only thing is, if it is a hyperbolic function, denominator is your s square minus omega square. If it is a simply cos or sine, and denominator is s square plus omega square. So this is all about your what, Laplace transform of cos omega t. Then another one is your sin omega t. So if f of t is your sin omega t, so already I told you, in sin omega t, similarly sin omega t if you express in terms of exponential function, that is your e to the power j omega t minus e to the power minus j omega t by 2j, j term will be there. Okay, so in case of sin h and cos h, there will be no j term. So that's why in case of sin and cos, there will be no j function, and there is no j term. So only sin and normal sin and cos, and there will be the presence of j. Okay. So now we are going to derive the Laplace transform of sin omega t. So Laplace transform of sin omega t, that is your what, Laplace transform of, in place of sin omega t, we will put this one, e to the power j omega t e to the power j omega t minus e to the power minus j omega t divided by 2j. Okay, so that is your 1 by 2j, taking the left side of the bracket, that is your Laplace transform of e to the power j omega t minus Laplace transform of e to the power minus j omega t, and the value is how much here, 1 by 2j. Here e to the power, already I told you, e to the power 80, that Laplace transform of e to the power 80, that is your 1 by s minus a, and Laplace transform of e to the power minus 80, that is your 1 by s plus a. Any exponential function of Laplace transform. Here a value is how much, j omega. Here a is nothing but is your what, j omega. So that's why e to the power any plus, that will be denominator, that must be minus. So 1 by s minus j omega minus 1 by, if it is minus, denominator must be plus, s plus j omega. Here a is nothing but j omega, and the value is how much here, 1 by 2j, and here s minus j omega into s plus j omega is your LCM, that is your a minus ib into a plus ib, that is your a square plus b square, that is your a square plus omega square. So that's why s plus j omega, here minus s plus j omega, and the value is how much here, that is your s, that will be cancel out, j omega plus j omega, that is your 2j omega. So that is your 1 by 2j into 2j omega divided by a square plus omega square. 2j that will be cancel out, that is your omega, that is your omega divided by a square plus omega square. So that is an important conclusion. Therefore, Laplace transform of sin omega t is your what? That is your omega divided by a square plus omega square. So that's why, so that is your important, that is your thing is what? Laplace transform of sin h omega t, cos h omega t, sin omega t and cos omega t. If it is a sine function, numerator must be omega. If it is a cos function, if you observe the previous slide, there is cos omega t, the numerator that will be s. And both denominator of sine and cos that will be same, a square plus omega square. Now both denominator that will be a square plus omega square as far as sine and cos is concerned. If it is in sine omega t, numerator must be omega by a square plus omega square. In case of cos omega t, that is your s by a square plus omega square. Similarly, in case of hyperreal function, sin h omega t is sin h omega t, that is omega by a square minus omega square. In case of cos h omega t, that is your what? S by a square minus omega square. So thank you. So next class again we will do more and more number of numericals based on the Laplace transform. Thank you.